Hello. Today we are going to look at Leetcode 128, longest consecutive sequence. So in this question, you are asked to find the longest consecutive sequence of an array. And in the first example, we've been given an array that has 100, 4, 200, 1, 3, and 2. Just from sight, right, from just looking at it, you can see that there is 1, 2, 3, and 4. 1, 2, 3, and 4, right? There is 100, and then there is 200. This is just 1, this is 1, and this is 4. And that is what we have here, right? The second example also has 0, 3, 7, 2, 5, 8, 4, 6, 0, 1, right? And from the look at it, just by looking at it, you can count from here that says 1 here, we have 2 here, 3, 4, 5, 6, 7, we have 8, and then we have 9. So we have 9 of them. But we can also see that there are 2 zeros, but we only used 1 of them. So what we can deduce from this is that we can remove just one of the duplicates, one of them, right? And also let's look at this again. Let's look at the first example again. Now I was able to get this answer just by looking at them and from my eyes, right, from just looking at it. But what you can also, how do you know that this is part of a sequence, or this is part of a sequence, or this is part of a sequence, right? Well, you can't know. So when you start looping through the array and you pick, say, 100, what you can do is 100 minus 1, which is equal to 99. Now, you can check to see is 99 in this list. If 99 is not in there, it means this 100 is the beginning of a sequence. It is starting a new sequence. So we have plus 1 here. Then we come again to check, is 100 plus 1 in here, right? If 100 plus 1 isn't in here, it means it's the end of the list, right? Then we know it's just 1 over here, just like we did from sight, right? Now we come to 4. Is 4 minus 1 in here? Yes, 4 minus 1 is in here. Now is 3 minus 1 in here? Yes, 3 minus 1 is in here. Is 2 minus 1 in here? Yes, 2 minus 1 is in here. Now is 1 minus 1 in here? No. So this is the beginning of a sequence. Now that we have 1, that is the beginning of a sequence. So we have 1 here. Is 1 plus 1 in here? Yes. Is 2 plus 1 in here? Yes, it's in here. Is 3 plus 1 in here? Yes, we can find it in here. So at the end of the day, we have 1, 2, 3, 4. So we have 4. So that is how you can ascertain that. The one thing you have to know, duplicate is really not necessary. It can make the list shorter and reduce the time we spend on the array. And then with this plus or minus 1 arithmetic that we do here, we will be able to tell the beginning and the end of a sequence, right? So let's go see how we can implement that. First, we want to remove duplicates. So nums can be equal to set nums to remove duplicates. Now for num in nums, if num minus 1 not in nums, then we know it's the beginning of a sequence, right? Or a streak or whatever. So let's say sequence is equal to 1. And then we can also say that the current num is now equal to num, because that's the beginning of a sequence, right? While now we are going to do the additions to check if they exist. Well, current num plus 1 in nums, we increase the streak by 1, or the sequence plus 1, and then current num is also now plus 1, right? Now let's get the max sequence is EQ is equal to max of max sequence, and then sequence. Right, we don't have max sequence initialized here, so let me get that set up. Return max sequence. All right. Awesome. Yes. So this is how you solve this in an O of n times. You can also solve this using union find algorithm. Maybe I will do a video on that. But yes, thank you very much. See you in the next one.